Let's practice all that we've learned about classes so far by solving some problems. Here is a programming problem with a class. We want to create a class to represent a student. This contains their name, their overall score, and the clubs that the student belongs to. We also want to store information about whether the student is an honors student or not. In addition, we want methods or member functions which allow us to update all of these values. We've studied in a lot of detail all that you need to do to set up a class and then instantiate objects of that class. What are the things you need to pay attention to here? Make sure that you pay close attention to the type of the various variables which store the different kinds of information. For example, the list of clubs that a student belongs to has to be a list. Whether a student is an honor student or not is a Boolean variable. Also, ensure that you set up the member variables such that they are not shared across all instances of the student class. You want the values stored in a member variable to be unique to that specific instance. The name of our class is student. Use the class keyword to define a class, and within that we set up our init function. The init function initializes the values of all the member variables of the student class. This is where you'll declare the member variables in order to have their values be unique to a specific object of a class. We have the name of a student, we have the overall score of the student, and instead of using a list to store all the clubs that a student belongs to, we use a set. Now, a set is better than a list because a set does not allow duplicates. You could have used a list here, but a set is better. And is honor student is initially set to false. You can set it to true if the student is indeed an honor student. Also note that all our member variables are prefixed with a double underscore so that they can't be accessed from outside the class. When you instantiate a student object, the only input arguments that you need to pass in are the name of the student and the overall score of the student. We now have to set up a bunch of methods or member functions which will update the various member variables. This is the change name, which updates the name variable. Then we have the change score, which assigns a new overall score to the student. The add club function adds a new club to the set of clubs that the student belongs to. Notice how we add to a set. We call clubs.add. We can also update whether a student is an honor student or not. And while debugging, it's always convenient to have a print function which prints out all the member variables of your class. This is an easy way for you to check what's going on. Once you've defined the class, let's instantiate some objects of this class. S is a student whose name is Jay and whose overall score is 87. This is all the information that we can pass in when we instantiate an object of the student class. Now we can add this student to the yoga club by calling s.add_club. Now s.printAll will give us the current details of the student. Jay has scored 87 and does yoga. He is not an honor student. That's the default value. A set does not allow duplicates. If we try to add yoga to our set of clubs, notice that the term yoga here has a lowercase y, whereas previously it had an uppercase y, which means these are not the same strings. So if you call s.printAll, you'll find that Jay belongs to the yoga and the yoga club, where yoga is spelled differently. The strings have to be an exact match for the set to consider them duplicates. So if we go ahead and call add club with yoga all in lowercase once again, this will not be added explicitly. This is a duplicate. s.printAll will show you that we still have the original two, yoga and yoga, with different capitalization. This is our student class with an ability to update all member variables. In this next programming problem, we are going to create a number of different objects of the student class that we just defined earlier. We are going to write a function which takes as its input a list of dictionaries. Every dictionary contains the details of one particular student. We have to convert this list of dictionaries to a list of student objects, where every element in the list is an instance of the student class. This programming challenge is actually pretty straightforward. There are no additional details. You just have to bring together everything that you've learned so far about dictionaries, about classes, and so on. Here is the list of student details called the student details list. You can see that it's a list because of the outer square brackets, and within the square brackets we have a number of different dictionaries. Each of these dictionaries contains information about an individual student. For example, the first student is Seema with an overall score of 89 who belongs to the yoga and chess clubs. Notice that the name and the overall score is present for all students, but for the student Ajay, we don't have the clubs that he belongs to. We have to account for this when we instantiate our student objects. We'll name this function getStudents because it takes dictionaries and returns student objects. The input argument to this function is the list of student dictionaries, the student details list. Within this, you'll instantiate an empty list, the students list. This is what we're going to return from this function. We can iterate over the dictionaries in the student details list using the for in loop. Each dictionary will be assigned to the student details variable. From the student class that we defined earlier, we know that the name and the overall score are compulsory or mandatory arguments. If we find that the information about a student is incomplete, if the student name or the overall score is not present in the dictionary, then we cannot instantiate a student object for this student. If the name key is not in student details or the overall score key is not in student details, we simply continue and move on to the next student. We'll come to this next line of code only if the name and the overall score key is present within the student details dictionary. We'll instantiate a new class of type student and assign it to the S variable. Access the values associated with the name key and the overall score key in our dictionary. That gives us the student name and his overall score. We then check whether the club's key is present in the student details. If the student does belong to clubs, then the information will be in there, and we call add club for every club that the student belongs to. We then check within the student details dictionary to see whether we have information on if the student is an honor student or not. We then call s.change is honor student with this information. Now that we've fully set up the student object, we can append this to the end of the students list. And that's it. The actual program is pretty simple. It's just all the little checks and the little details that you have to worry about. Let's go ahead and invoke this function on our list of dictionaries. We store the returned list of student variables in the students variable, and then we can print this out, and you can see that we have 4 student classes. Each of these are different instances of the student class. They are located at different memory locations. And to see the actual students, you can simply iterate over the students and print out their individual information. And here are the details in the individual student objects. Let's get some more practice using classes. This time you need to set up a class called circle. This class takes as its input argument the radius parameter, and it has methods which calculates the area of the circle and the perimeter of the circle. We'll use the value of pi from the math module. So go ahead and call import math and then set up the circle class using the class keyword. This circle class has exactly one member variable, and that is the radius of the circle, which we'll define in the init method. The get area function is very straightforward. It takes in no input argument other than, of course, self, the mandatory input argument for any member function of a class, and then returns the area of the circle, which it calculates using the pi r square formula. The next member function is the get perimeter. This once again requires no input arguments other than self, and we calculate the perimeter by calling 2 by r. We'll set up a new circle here, instantiate a circle of radius 12, assign it to the C variable. We can call C.getArea to get the area of the circle and C.getPerimeter for the perimeter, and both of these are printed to screen.